and welcome back. Now in this video we're going to be talking about automation, which we covered sort of slightly in a previous video using the ESP8266-01 module, and all it did was turn an relay on and off. Well, it didn't actually, did it, because there was a fault with the design, but since then I've played about with it and it all works. But that's not really where I want to go today. It's much more automation of this new workshop from which I'm recording my very first video. So yeah, I know you can probably see it behind me. So it's an ideal opportunity for me to just show you around the workshop as I describe what the automation is that I have in mind, and whether or not this item is going to be of use in dealing with that. And I can tell you as a spoiler, I've already thought that yes, this will help, but it's not going to do what it perhaps would be normally used for, that is switching something directly on or off. I want this particular piece of automation to be more sophisticated, so it's still going to use an ESP8266 probably. I haven't decided exactly what I'm going to use yet, but I need something with Wi-Fi capability because I want to control the automation with both my phone, which this allows as well, of course, and within the house and not the workshop. It'd be nice if I could control it with my Amazon Echo as well. I nearly said the dreaded word there. Let's first of all think about what I'm going to do. I'll just draw out a very quick picture of what I expect the automation to do in the longer term. It doesn't have to do everything in one go, but when I build this, we most certainly do want it to be extendable, or extensible, is that the word? Anyway, we don't want to lock it down and only have it do one thing and then think, should have thought of that at the beginning. So this is what I want it to do. Let me draw a diagram for you. In my workshop I have a heater, and in the cold weather of course it'd be nice for the heater to come on at either predetermined times or on demand, or when the weather gets particularly cold you want some kind of protection. So I've been thinking about how to do that, and not least I have various circuits in the workshop now, some of which are permanently live, like the ones that control my computers. They're always on. But there's another circuit that is switched by a big kill switch by the door, which I'll show you in a minute, and that needs to also kill the heater. So let me draw this. I'll take myself off while I do it. So somewhere in the workshop we have a heater. Now this is all mains voltage, so yeah, it's 240 volts, and currently this is connected to a consumer unit. A consumer unit is what's known in the UK, it's a fuse box effectively. So over here we have a consumer unit with a breaker in it, and that is connected directly to the heater. Now when I say directly, alright, there is a switch on the wall, and the heater itself does have a built-in timer and a thermostat, but the thermostat is pretty naff. It's, you know, a bimetallic strip, so it's not very accurate, and of course it's measuring the heat, I'm guessing sort of the incoming air here, right, because the control's here. So I guess as the air is drawn up and expelled out the top, it somehow measures that incoming air, which this is in quite a tight place. That's probably not surprising that it's not very accurate. Now, as I said before, I have a kill switch by the door, so as I leave in the evening there's a big switch here which we'll put down as kill. Now that's controlling a separate circuit from the consumer unit coming via the kill switch, and then from there it goes round the workshop, and at various points there are sockets. There's 4 in fact. So these are the sort of things that get connected to soldering irons and meters and power supplies and stuff. The sort of thing that you would not want to leave on accidentally overnight. Okay, so as I leave, I hit the kill switch, all this goes off, everybody's happy. Except of course within 2 days of having the workshop, I hit the kill switch, left it, and found that the heater had been on overnight. So I don't know how much that cost me, but it's not something I want to repeat, not least because I don't think it's particularly safe leaving a heater on 24 hours a day, never mind the cost. So what is it I want to do? Well, ideally I want some kind of control within this power line to the heater, So it's not controlled just by a simple miniature circuit breaker in the consumer unit. So we don't want a direct link. What we want here is some kind of switch arrangement. Okay, now of course the simplest switch arrangement would be an actual switch, but like the kill switches. But I don't want that either, because then you can't turn it on remotely. So this is going to be, if you haven't already guessed, some kind of relay. Okay, and lots of relays are powerful enough within the Arduino world to supply a heater, because, well, to be quite honest, I've lost the documentation temporarily for now, but I'm sure this isn't any more than 2 kilowatts. So if you're talking about 10 amps absolute maximum, most of the relays that are supplied with the Arduino can do the job. But we'll just see what sort of relay it is that I use eventually. So if there's a relay, we need to control it somehow. So some kind of controller is going to have to energize a coil. So this is all low voltage, so 5 volts or thereabouts. That's going to be the relay connected to there. Great, so this isn't, well, let's not say Arduino, because we know it's not going to be Arduino. It must have some kind of Wi-Fi capability, so it'll have a little aerial, like an ESP8266 for example. And then if we built this right now, this very second, how are we going to control that relay in this manner? Well, you've already seen a number of circuits that I've shown you with either Bluetooth or Wi-Fi enabled, which means my phone, in fact I'm going to use a different colour simply because I have several colours. So if this is my phone, and we'll put a little stubby aerial on it, just about see that, can't you? Yeah, so this is my phone. I could write a simple little application using MIT App Inventor, which I've shown and will show again, which basically has an on and off button at the very, very simplest, and that will just join into the Wi-Fi, and this will receive it, and we can control that relay from within, well, within the Wi-Fi cloud of my house basically. Great, so that means at least I can do it remotely. However, given that this is Arduino land, Arduino and related products, it would be child's play, I feel, to put some kind of thermistor in here. Right, so degree, I'm not sure if we have supposed to put T or C there. Let's put a C, centigrade, because that's what we work in Europe. Fahrenheit obviously for Americans. So a thermistor in here, we could easily have some kind of frost protection just by putting a simple thing in there and going, is the temperature below, I don't know, what would be safe, something like 8 degrees centigrade, around about, I don't know what that is actually, about 40 Fahrenheit, something like that. So far enough above freezing, but not too much that you get condensation inside your workshop. So a thermistor, and that could be a DHT11, which I don't like particularly because they don't go down below 0, but I'm hoping that my workshop doesn't go down below 0. In fact, things have gone terribly wrong if it has. So DHT11 would be good, and that also then does humidity as well, although I'm not quite sure how that's going to help me here. So that would be easy enough to do. And what else could we want to add on here? Well, as I've already mentioned, I have this 4-channel Sonoff. Is that how you pronounce it? Sonoff or Sonoff? Which I want to be able to control other things. This is a 4-channel one. One of the channels will be then plugged into here. Now when we say plugged into, obviously the Sonoff, in case you're not aware, has mains input and then 4 mains outputs, and they're normally used for controlling things like lamps and, well, TVs, I suppose, anything that is mains controlled. However, this isn't going to be mains controlled, so the input from the Sonoff here, we don't want mains, so what we'll probably do is use one of those little 5-volt transformers, I suppose you call them, or step downs. The one I showed you in the video that's on screen now, and we're wondering about whether or not it was safe to use. So the one I was showing was this one, and we wondered about that, and then we compared it to this one, which is fairly well thought of as being safe. So we could easily use one of those there. So mains in, or put this somewhere near the Sonoff, somewhere further away. So let's draw that in over here, which just about gets into the picture, doesn't it? So if this is my Sonoff 4 channel, one channel of which goes into there, and the 5 volt output, basically you only need one channel then, would go there like that. So that's all nice and safe, and it's only 5 volts. And we can put this component, if we've got any reservations about using this could be put inside some kind of metal container or something in case it did burst into flames. I don't expect that for 1 minute, but the option's there. So that's fine. So that means the Sonoff then can control the heater. So you can say something like, nearly said the word again, Amazon Echo, please turn on my heater, and it'll go, fine, I'll turn on your heater on demand. We want to make it slightly more sophisticated generally though, so that this knows that overnight there should be some kind of temperature protection, but during the day when the temperature's higher it never has to turn that on. And when the kill switch, which is here, has also got to be connected into here, but once again we don't want mains going in, so we'll probably use another one, well possibly this very one in fact. So the kill switch goes into there and supplies 240 volts, and out of there is another 5 volts. So now we've got the Sonoff coming in here, and we've got the kill switch in there. Basically, when the kill switch is live, that is, I'm in the workshop, or in and around daytime probably, then everything else goes by the board. I'm in, the heater is on or off depending on what temperature I set on here now, or perhaps via my phone, and that's it. Nothing else has to happen. I probably wouldn't use the Amazon to control the heater whilst I'm in the workshop, although, well, you never know, I might do. So whilst the kill switch is on, I'm in the workshop, this takes precedence. Yes, I'm in and around. It's all very simple, on or off, depending on what temperature. So what are we going to do on this device here? Well, we need some kind of LCD display to say what we're going to set it to, and then there must be some controls on here with which to set the temperature, and the easiest might be actually on the phone. So the phone could say on, off, or possibly on at a certain temperature. That doesn't look like an at sign, does it? They said don't touch this when it's wet, now you know why. On at, I don't know, say for example the temperature would go down, say we wanted to have a target temperature of I don't know, 21 degrees, which is around about, I think it's about 66, 68, something like Fahrenheit. So on at 21 degrees, this then receives that, displays what the target on, a bit like the Hive central heating controls we have in the UK, but basically it's just a remote control thermostat. So this will receive that, display the temperature here, say yes, I'll try and keep it at 21 by reading this, and everything's hunky-dory, isn't it? Except that this might not be in the right place. This DHT, whatever it is, 11 or 22, is going to be physically located around here. We might want a remote one that I can place right here next to my desk and go, I want the temperature here to be 21, not back there somewhere, here. And when it's 21 here, then I'm comfortable and warm, and that's it. So that's potential. What we can have a little tiny remote here, Wi-Fi again, and degrees C. We can set that. As I say though, some of these are thoughts of the future. I just don't want to close any route off. And the best thing about it is, of course, having an Arduino based controller module, even if it is ESP8266 at the end of the day, means we can do anything we like with these inputs, doesn't it? All it needs is a GPIO pin and one analog pin for this. Now we have to be careful with the ESP8266 because you only get one, so this might be it, just the thermistor. This one would require a GPIO pin because it's sending data, isn't it? So this is on Wi-Fi. It'll be very simple to send something across here in a sort of a data packet. Okay, so that's generally where I'm going with my ideas. As it happens, the weather's warming up in the UK at the moment, whereas when this whole thing was being built, it was very cold. In fact, they had to stop building because the snow arrived, which was fun and joy, believe me. Never a stress-less moment, I can tell you. And I'll put a quick speeded up video of how they built it very quickly. Right, let's have a quick tour of the workshop now, so you can see how these things all come into place, and well, give you an idea of how I'm setting it up. Still setting it up, I might add, because these things don't come together within a couple of weeks. Since this workshop's been up, it's going to take a bit longer than that, I suspect. In fact, several months as you tweak it and things go on and off. And of course, I've got dozens of components still to store away. I have a spreadsheet stroke databasey thing. It's not a database, it's a spreadsheet, but it's a bit more sophisticated than just a list. And yeah, okay, right, I think it's time for a tour. I'm going to take this video camera with an SD card in it and a battery now. First time I've ever done that, by the way. And tour you around the workshop, just showing you where all these bits and pieces are. That's the second time I've knocked that over. And you'll get a better idea. And I'll talk about storage as well. Okay, right, let's get on with that. So this is the entrance door, and just to the right of that, as you can see down here, there's my light switch and what I call my kill switch. So that kill switch behind the panel is connected up here in the consumer unit to a single circuit. So you can see in there there's 1, 2, 3, 4 circuits in total. The one that's off at the moment is the heater, hence the desire to make sure that this is all very much automated. And this one here at the end, that is the kill switched version. So that's all nice and neat and easy. So what I want to do somehow is have this as an input to the microcontroller solution that we've come up with, and have that determine when it's on, like now when I'm in here, that the fire will stay on up to a certain temperature. Great. Now to the right of all that, you can see some component drawers here. Now these have been sort of just stacked here while I determine exactly what I'm going to do with them, because these are so old. This bottom one, for example, is so old, it must be 30 years old. That's going when I've found a home for the components, if indeed I choose to keep them. This next one, well, I don't know whether to keep it or not. It looks okay actually, so I might. The one behind it, which is quite much bigger than you think actually, that contains all the resistors that we've got. Unfortunately, I think that's only an E12 range, so I've got a much bigger range now, which I've mentioned before, so that probably won't hold them all, but we'll see. Up here you can see various boxes of stuff above the window that have yet to be sorted out. It's a sort of a bit of a dumping ground at the moment, but they're sort of screws and bolts and nuts and nails and stuff. So back by the door again, now below the window, this is my main DIY bench here. As you can see, there's some bits on there that I'm currently looking at. There's the window, there's Benny's cage, you can just see below the blind. And this bit here, this is my soldering station. Now this is quite nice because it means I can actually sit down now and do my soldering, and there's my scope at the back and power supply and whatnot. I'm actually trying to fix a second version of that vacuum cleaner that I had on my blog. If you haven't looked at my blog yet, please do, there it is on screen. Now this one, I tested it, and would you believe it, it's still playing up. So I'm going to have to add a further resistor, which you can probably just make out down there, and then all will be well. So on the left I have a further power supply, my original power supply, that's now really been superseded by that better one there. It's got current limiting and voltage control and what have you, but that one's still good. I'll be using it no doubt. And there's a signal generator at the back there, and multimeters and various other bits of equipment still in their cases up here. Now if I swing round left, this is my computer desk, and this is where I do a lot of my videoing. As you can see, this is where that board was that you just saw. There's my microphone, and above the window there's various books and what have you, not particularly organised very well at the moment. To the left of my desk then, There's my PC in the corner, very small PC, but it's a quad i5, so plenty powerful. Above it, a little bit more storage that I haven't really organised very well because it's the original stuff and I couldn't really get to it very well, but that will be properly organised in the coming weeks. And then of course over here, further to the left, we have my new mini bin organisation. As you can see, there's lots of bins. There's 75 of these little ones. If I put my hand there, you'll see how small they are. Yes, ideal for Arduino components, of course. And down below, they're just a little bit bigger. These ones here are a little bit bigger and contain things like wheels and stuff, for buggies and whatnot. So that's great. And below that, there's another shelf. That there is Benny's mat and cupboards and things underneath. Now these cupboards aren't particularly well organised yet because I've just thrown stuff in just to get it out the way, but they'll all be organised properly over the next few months. Underneath, that's a printer. Moving backwards, I'm going backwards towards the door again now. So next to the bin, this is all my DIY stuff up the top here. Once again, not particularly well organised, but it's, well, you should have seen it a couple of weeks ago when I first started it. More Arduino stuff there. This will all be sorted out, but I suspect it will take several weeks before you realise, you know, what bits you need handy and which bits you don't. And over here, to the left of the door and looking down now, there's the heater unit, and right over there in the corner there's the on-off switch, and behind that heater there is in fact a timer and temperature control, neither of which are particularly easy to get to now because I've got this racking in place, but also it's not particularly accurate anyway. So that's it, and then we're back to the door. Yeah, well, but as a workshop though, it's about the size of a, I don't know, a bedroom I suppose, something like that. Oh, that is the front doorbell, and with any luck that's Amazon delivering some insulation rubber for me. So there we are. Right, I better go and pick that up first, and then we'll come back to the actual project. And Ben has decided to have a quick visit and inspect my organisation. If I say that word once more, I'm going to hit myself. Yeah, that's it, Benny. Do you think it's all right? Do you think it's organised a little bit too much? Oh, hello, what's that you knocked over? Yeah, no, it's not very tidy at the moment. I'm in the middle of a job, you see, Benny, trying to sort out the Hoover. Is there anything you want to say to our viewers? What's that? I need to have a good tidy up. You're not kidding there. Yeah, but do you like it? That's the question. Do you like the new workshop, Benny? I think he probably does, doesn't he? He's having a good sniff around. It's always a good sign. Okay, well, we'll leave it there. Perhaps you can give me a hand later on in the video editing. Is that all right? And this is a view from the outside. There's Benny's cage or cat run on the right and my workshop on the left. Turn. Right, so that's it. There's a good view from inside. Right, that's the workshop. Now you can see what I want to automate regarding the heater. So let's think about a little bit more how we're going to do it. Now, just before we talk a bit more about this project, there is, of course, the spreadsheet that I'm putting together for all those components you saw in those little bins. And they look, or the spreadsheet looks like this. Now then, what can I tell you about this? Okay, there's a part description, as you can see down this side, this column. A category which sounded good at the time, but I can't quite think what to put in there at the minute, but I might think of something in the future, you know, whether it's like microcontroller or sensor or connector or something like that. Then the part number as we might know it, or Banggood knows it, or AliExpress or somewhere. And then of course the location. Now S at the beginning of one of these means small bin and M means medium bin, but as it happened I'd labelled the bins 1 to 75 for the small bins and then started at 100 for the medium bins anyway, so I didn't really need that prefix, but it doesn't matter. It's I just find it useful now. I'm used to it, having typed all this in, as you can see, and this is nowhere near what I've got. I've got loads more stuff to put in. I'll keep it at that, and a few notes and things. Now the slight enhancement I've done to this, Let me just enable the content. Right. So when, for example, this AT tiny programmer, right? Fine, okay, all well and good, but where did I get it from? Doesn't say. If you think, what else is there to know about this? If I remember to keep the information or PDFs or whatever documented at the time of doing this, then all I've got to do is press some hotkeys on my keyboard, say Control J, or go to that. There's a button at the top. See that button there? That's equivalent of more info. So what's it going to do is it's going to jump to the sheet that is the numeric version of this. In this case, it will jump to sheet 2. And I can just show that by pressing more info. So as you can see, we're now on sheet 2. And then if I press Control H, it will jump back to the index from anywhere, because this will go off. I'll show you now. Let me just press Control H. My keyboard, unfortunately, is over on the other shelf now when I'm doing videoing. Jumps me back again to where I want to be. Now, you might think, why don't I just click one of the tabs down below to get back to my index, or indeed one of the sheets? But of course, when you've got 75, they're going to quickly disappear off screen, aren't they? So if we go to a hide numbered one, I haven't got anything over 75 at the minute, so let me just scroll down and find something. Yeah, I think S20 would be enough to get it off the screen. So Control J. So there we are. Now we're on sheet 21, as you can see down here. But where's the index tab gone? It's disappeared off the left, isn't it? So the only way to get it back normally would be to scroll, but that's all a bit too much faffing, isn't it? Having read the wonderful bit of information I got on here about this particular item, I just press Control H and back I go. So it's, you know, a poor man's database, isn't it, really? But I really couldn't spend the time trying to develop a proper database system when I just don't need it, not for home use. So there we are. That's well, I'm finding it useful, and it'll probably gradually evolve over time. If anybody's interested, give me a shout. You can have a copy by all means. Right, back to the actual solution then. Next steps, I suppose we could say. We can easily put in one of these boards, right? And let me just get a board that I might very well use. We said ESP8266. As long as I only need one analog port for Mr. DHT11 or something, that's fine. As soon as I want another analog port, I'm a bit stuck because I don't want to start going into pin extenders and stuff like that. But even then, we have a solution. Let me just show a couple. So here's two potential boards I might use. This one is just a standard ESP8266 board, ESP Arduino. Why would I use this? Well, frankly, I don't like the big socket. So as I'm not going to use that, apart from programming it, and the fact it's got two buttons on here in order to flash it, which is quite faffy to do, the newer ones of ESP8266 boards tend to just have the one button. They've solved the problem how to flash it without having to press reset. What you have to do is press flash, then reset, then keep your finger on the flash but release the reset. At least I'm pretty sure that's the way. Yeah, that is it. And then it says at that point I'm uploading and you can just let go. But it's a bit faffy, to be quite honest, and I don't know, 3 times out of 10 it just decides not to work anyway. It just says I can't connect. So this board, being a bit old now, and with this huge big socket that I just don't like using for general development use, I might use one of those for that. So that goes there. Or if I do need more flexibility in terms of analog ports and things, there's this one which I haven't even tried out yet. Now this is, it says it's a WeMOS, even though it's backwards on there, which is always a bit of a danger sign, isn't it? When you get things printed backwards, does it mean it's a clone of a clone? I don't know. Because I think it's by Robot Din, isn't it? Yeah, Robot Din. Designed by Robot Din. Probably built by WeMOS. But basically what this is, I've mentioned it before briefly, it's an Arduino AT328P. So that's exactly the same as an Arduino Uno on this side. And over here we have the ESP8266, all on the one board, which is why there's a lot of components on here. And these little dip switches, I'm just looking for my pointer on having to use my fat fingers. So these little dip switches here, which I can probably get in, there we are, they determine, in fact it's upside down, isn't it, for those things, on and off and all this, these switches determine how the Arduino is connected to the ESP chip. They can either run totally independently, or you can join them up. And somewhere, yeah, I think that might tell us. Oh, upside down again. No, that's just this pin out. I've forgotten some information somewhere that tells me exactly which of these dip switches I've got to flick across when I want to program this compared to this, for example. Obviously there's only one port, and you want to be able to address these chips totally independently. So that's another option, and as you can see, it's got 6 analogs for the Arduino, and there should really be one for the ESP as well, but as I say, I haven't really looked into it that much. And maybe the ESP is only connected to the analog via the serial data pins or something like that to act as a sort of a Wi-Fi module. So it's almost like an Arduino with an ESP shield almost, isn't it? It's just on one board. Anyway, so that might do for that as well. I'd rather use that one because it's just a little bit easier to do, but I will use that if I need to. We've talked about the relays. Yes, the kill switch goes to the relay and 5 volts comes out of that, but I'm almost tempted to put some kind of opto coupler in there. So the 5 volts with a resistor, you know, something like 180 ohms or something, goes through an LED opto coupler, ditto with this one, so that my Arduino board or ESP8266 board is totally protected. So I don't really fancy any one of these going wrong and frying the board. It's just no need for that. So a couple of opto couplers might be on my next shopping list on that for that slow boat from China, which incidentally sometimes is very quick. I've had stuff delivered within a week. I don't know how they do it and why they can't do it all the time, but there we are. So what I'm going to do, I think, initially is probably build something for that board underneath, the Wemos ESP8266, just to get something up and running, possibly with this and maybe with this, because obviously I want to get my Sonoff running, because that means I can use my Amazon, not going to say it because it will spring into action, get it working with that, my Echo, just to prove it all works, because then I know it will work in the house as well. I can use it on my phone with a nice little app. So, and all that can be built fairly quickly and just have access to the other GPIO inputs to control it with remote sensors or what have you. And then of course the imagination is my only limit, isn't it? What I do with the phone, I can have timed inputs, I can have temperature controlled limits, you know, frost protection, any number of things. So that's where I'm going next. Now, talking of my workshop, you've seen the inside, you've seen a quick picture of the outside. I'll leave you with a speeded up version of how they put it all together, okay? Which is quite interesting actually. But of course, once the shell is up, you don't really see what's going on inside too much. But it's interesting nonetheless. I'll leave you with that, and we'll resume a bit more technical service on my very next video. Okay, so thanks very much for watching. Don't forget to leave comments and stuff below, and see you in the next video. So here we have a speeded up version of my workshop build. The first thing they had to do was get the shuttering off the concrete that they'd poured, and that was a bit more work than they thought, because there was all the snow and ice and everything, so I think it was a bit of a rush job. But eventually they managed to get it off, so we have a nice, neat, square and perfectly level base on which to build a shed, which is why I got them to do it, frankly. So then they start bringing in the floor. Now look at this next one as it comes in. You'll see that white underneath. That was in fact the polystyrene insulation, because obviously in a workshop your feet are pretty much constantly in contact with the floor, and a lot of heat is lost that way. Now they've got to lay, I don't know quite what they're doing. There's some sort of frame I think they're putting round now for the panels to slot in, and then they've got to lay some plastic, but I don't know what that green stuff is. Some cable for something. Didn't really understand that bit. So now they're putting the plastic down so they don't damage the floor while they're building it, and they take that up at the end, of course. So there's the first panel, and it all comes flat pack, because what they've actually done is build it in the factory and then disassemble it. There's me inspecting their work. Now what you can see here is the uninsulated walls. That blue is the vapor barrier, so the workshop stays nice and dry. Eventually that gets filled in with some insulation, which I'll show you in just a sec. All the windows are double glazed because in the UK we get some pretty yucky weather most of the year, actually, not just in the winter. So now they've put that up, of course they're blocking a lot of what's going on, but whilst that's happening, as soon as they get the final panel on, the electrician turns up and he's doing all sorts of stuff on the inside, running cables in. Now one of the interesting bits is, oh, they're putting the roof up first. I've got some better pictures of the roof actually coming up later. And he had to go up there on a ladder and get some hot, what do you call it, a hot air gun. Well, it was more than that, it was a butane gun. And weld in some more sheets. But anyway, while all this was going on, the electrician was inside drilling holes. And he said, take some pictures before they put the cladding on the inside, so that I can always look at the pictures in the future to determine where the cable runs are. Now as it happens, since then I've found out that my cable finder and stud finder things does actually work even through this 1/2 inch plywood, but it's always good to have the pictures to have a look at first so you know where the cable runs are running. I'll show you those in a sec. Okay, so this is the tar roof being put on. And if you notice that on the extreme left bottom of the picture there's a couple of cables poking out, and that's where the outside double socket's going to be fitted. Oh, there's some more cables there. Yeah, very thorough job, quite frankly. They've got some beading and trim and all that kind of stuff to put on yet as well. Right, I think we'll have some pictures now of, these are still pictures by the way, in the next few, of the roof going on, and then of course the final product. Let's just wait for him to put that outside socket on, shall we? This was all done in a day, by the way, or less than a day. I think they left about 4 o'clock, they turned up about 8 and left it floor. There's the outside socket. All done by a professional qualified electrician, so I got my certificate saying it all conformed. Right, so this is the inside now with the insulation and the cable runs. So you can see it's twin and earth, 2.5mm 20 amp radial circuits. So I've taken pictures of all these so that I can always double check where the cable runs might be before I start screwing things to the wall, which incidentally I'm trying to avoid like mad. And for all those American viewers who think, hang on a minute, I can build a log cabin in 6 hours, yeah, believe me, I would have loved to have done it, but I just haven't got the time or the expertise to do that. Right, so here's the roof being put on from an upstairs view now. And as you can see, all this is prefabricated, and the roof itself is insulated in pretty much the same way as the floor was. It's got polystyrene stuff on the inside, and in the cold weather that I had immediately after the installation of the shed, I can tell you it's pretty toasty warm in here with minimal heating. And in fact, once it's heated, it keeps the heat in as well, which is always a good sign of insulation. There it is, pretty much done. I mean, obviously the roof hasn't quite completed, I haven't got the door on yet. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.